This section, we're going to talk about integration by substitution. And first we'll do some very basic problems. Won't even involve substitution. You're supposed to know that the integral x to the n dx is x to the n plus 1 over n plus 1 plus c. If you don't believe that, that's fine. Take the derivative of this and see if you get back x to the n. And since you can't divide by 0, this rule does not work when n is negative 1. For example, if you have n is negative 1, well, it says to add 1 to the power. Okay, you add 1 to negative 1, you get 0, but then you divide by 0. And fair enough, x to the 0 is 1, but you can't divide by 0. Okay, so n cannot be negative 1. Now, let's do some basic ones, just a few. If you have the integral of x to the 7 dx, very simple, add 1 to that power, divide by that power, plus c. If you have the integral x to the 17 dx, add 1 to that power, put it at the power, and then divide by that same power. Now, let us review something. I'm sure we talked about this before, but if you have a fraction and you want to add 1 to it, well, think of the 1 time and 1 time only as b over b. So now we have a common denominator and we just add the numerators. If you want to add 1 to that fraction, how can you more quickly get to a plus b over b? Oh, you mean the numerator, you just add the top and the bottom. That's the numerator. And you keep the denominator. So if you have 2/3 and you want to add 1 to it, rather than thinking of the 1 as 3 over 3, much quicker. Add the 2 and the 3, get 5, and keep the same denominator. That is what 2/3 plus 1 is. Negative 1/3 plus 1, you add the two numbers, you get positive 2 over the 3. You're gonna have to know what negative 1 plus 3 is, even if you do it the long way. If you think of the 1 as 3 over 3, you're still gonna have to know what negative 1 plus 3 is. And every time you're gonna be adding those two numbers. Because where does this 3 come from? Sorry, how do we replace the 1? We place the 1 with that number on the top and the bottom. That is, adding those two numbers is always going to be the same as adding those two. So it isn't, oh, it's easier to do it another way. No, add the top and the bottom, that becomes the numerator. So if you were asked to integrate x to the 1/3 dx, it's routine. You add 1 to that exponent. Oh, that's a fraction. I'll add the numerator and the denominator, and I'll divide by the same denominator. Then you need to divide by 4/3. 4 over 3, plus your constant. The integral of x to the negative 2/3 dx, well, add those two numbers, you get 1, divide by 3, then divide by 1 over 3. And dividing by 1 you don't have to bother with. Plus c. If you have a negative exponent, doesn't matter. Add 1 to that number and then divide by that number. There's an understood 1 there. When you divide those numbers, you get negative 1/6. times this. But I don't like negative exponents, so I'm going to move it to the denominator as x to the 6th. If you have the integral of x to the negative 5/2 dx, well, you add those two numbers, you get negative 3 over 2. And then you divide by negative 3 over 2. Well, in terms of the number, it's negative 2 over 3 times this in the numerator. But I'm going to put it in the denominator to make the exponent positive. Plus c. Don't forget the plus c. You're given a 10-problem exam and you quote get them all right, you're going to lose a point on each of those problems if you don't write plus c. So your 100 grade is going to go to a 90. Your 65 grade is going to go to 55. Your 82 is going to become a 72. Don't do that. Now, just want to tell you that the integral of u to the n du, as long as those match, just like x to the n dx, those matched, it's the same answer. Add 1 to the power, divide by 1, plus c. And and n cannot be negative 1. There's no difference between u and x, or v, or w, or y. Somebody asks you, what's the integral of, y to the n dy, or let's do one more specific. If you were asked to do y cubed, well, this would just be y to the 4 over 4 plus c. As long as those letters are the same, that's all that matters. They can be anything. Now that we reviewed, let's do some real U-substitution problems. So once again, other than using a different letter, right now, this is the only integral that you know how to solve. So suppose you were given the integral of x squared plus 4x to the 5th times 2x plus 4 dx. Generally, not always, you should let u be what's being raised to the exponent. And I'm raising something to the 5th. So I let u equal to x squared plus 4x. That means that this piece is going to become u to the 5th. And each and every piece in this integral has to be accounted for. Now, a lot of students will say, okay, so du is 2x plus 4. Okay, well, if I buy that, fine. So instead of 2x plus 4, I can write du. Okay, wonderful. So I justified that. But what about dx? Okay, you have to be honest. That is, you can't say, well, that's u to the 5th, and that's du, and, oh, we're just going to ignore the dx. Nonsense. You can ignore stuff. You can ignore it. So maybe you go back and you try to figure out what your error is. Okay, every piece has to be accounted for. Not most pieces, not some, all. Well, your error is here. Du does not equal 2x plus 4, but rather it equals 2x plus 4 dx. So this whole piece is du. Now I accounted for everything. And this is a simple integral. It's u to the 6th over 6 plus c. Now, if somebody gives you an integral in terms of x, and you say, oh, I know that answer. It's u to the 6 over 6 plus c. You're going to get an extremely strange look from the person you give the answer to. They give you an integral in terms of x, and you give back an answer in terms of u. You need to restate what u is. So yes, it's u to the 6th over 6 plus c, where u is x squared plus 4x. Now, right or wrong, if you tell your boss that that's the answer, he or she will say, okay, I hired you, I have to trust you. But if you say u to the 6th over 6, they're going to know that they can't use that answer because they don't know your code. Your code was u equal to x squared plus 4x. And not everyone knows what you're thinking. You could have made a different substitution. Maybe not that problem, but there's many integration problems where you can make different substitutions and get the right answer. Suppose you have this. Now, the headache here is this is being raised to the first and that's being raised to the first. Looks like, nothing's raised to anything. But again, you want something to be u and something else to be du. Well, if I let u equal 3x squared, then du will be 6x. Don't forget the dx. Well, that's not 6x. So that didn't work. Did you make a mistake? Absolutely not. U equals x cubed plus 2. So the differential will be 3x squared dx. Ooh, that's just what I have. So what you have is this is u and that's du. Well, you're just going to have to realize, hey, how about I think of it as u to the 1? So then you're going to have u squared over 2 plus c. So it's going to equal to u squared over 2 plus c, where u is x cubed plus 2. Don't try to remember what you let u equal. It's right on your paper. It's right there. That way you don't make a silly mistake. Now, if you were to take the derivative of this, you will get this back. If you don't believe it, let's see. So we have x cubed plus 2. You bring down the 2, it's going to kill off with that 2, and the power is going to become 1 less. Then you take the derivative of what's inside. But that's exactly what we have. There's no difference at all. Okay, so it worked. And of course the derivative of plus c is 0, and adding 0 doesn't do anything. Okay. A good rule is generally let u equal to what's being raised to a power. If there is no power, well then the power is 1. Now, this here, the denominator, this is x squared plus 1 to the half. Something's to the half. How about I let u equal to x squared plus 1? So then du will be 2x dx. Well, that tells me that the denominator, well, that's u. I know, it says so. So that's u to the half. So I took care of all of this. And x dx, well, I have that. I just don't have the 2. Well, you can put in a constant, not variables, as long as you counter it by putting the reciprocal outside. So now here's the constant. This numerator is now du, and the denominator is u to the half. So this becomes 1/2. Let's bring the bottom up to the top, because we only know how to integrate u to the n du, not 1 over u to the n. So here's the half. The half times this. Well, I add 1 to the power. -1 plus 2 is 1 over 2. Then I divide by 1 over 2 plus c. So I just get the square root of not 6, but u plus c, of course. Get the square root of u plus c because, the 2's cancel out, the 1's cancel out. We're just left with u to the half, which is the square root of u. So the answer is the square root of u plus c, where u seems to be x squared plus 1. How about we have this problem? The integral of 5x times the cube root of 1 minus 2x dx. Now, unless you see that you're going to need the 5, I generally like to bring constants out in front right away. So it's 5 times the integral of x, and I'm going to write that as 1 minus 2x to the 1/3 power dx. Like I've been saying, generally, let what's being raised to the power be du. Notice you can't distribute the x now, but in a moment you will be able to. So du, if you need to, is -2x dx. Well, there's the 5. This part right here, I dealt with the 5. That part right there is u to the 3rd, and x dx. If I had a -2, then this times that. It's in front of me, it's du. But if you put in, or if you multiply by -2, you better divide by -2. So that's -5 over 2, u to the 3rd. This here is u to the 3rd, and everything left over is du. So here's my -5/2 times the integral. I add 1 to the integral. 1 plus 3 is 4 over 3. Then I divide by 4 over 3 plus c. So I get -15 over 8 times u to the 4/3, where it says it right there, u is 1 minus 2x plus c. Suppose you have, I want to go back to an earlier problem. I want to go back, solve it over here. I want to go back to this problem. An alternative way to have done this problem could have been to just distribute 3x to the 5th plus 6x squared. And that's a routine problem. I can integrate the first plus I can integrate the second. When I integrate the first, I get x to the 6 over 2, because the 3's will cancel, plus 2x cubed, because this 3 will cancel. 6 over 3 is 2. Okay, plus a constant. And, oh, beautiful, beautiful. So Now, let's look at this more carefully. So here, I got this answer, and over here, it looks like I got something different. So let us look at what's going on. If I square the x squared plus 2, I'll get x to the 6 plus 4x cubed, 4x cubed plus 4 all over 2 plus c. I'll divide those. I'll get x to the 6 over 2 plus, I'll divide those two, and I'll get 2x cubed, and then I'll divide 4 over 2, and I get 2 plus c. And you say, ooh, somebody made a mistake. They don't look the same. Well, if you notice, they both have x squared over 6, and they both have plus 2x cubed, but this has 2 plus c, and that has c. Well, 2 plus c is just another constant. Okay, this c is 2 less than that c. That's why when you add 2 to this c, you get that one. They differ by a constant. That's fine. That is fine. They can differ by a constant. Okay. So sometimes you don't have to use U-substitution. You can just multiply out. 2x cubed to the 8th power. Like I say, usually it's a good chance, it's a good idea to let u be equal to what's being raised to a power. Now you may say, okay, there it is, x is being raised to the power. So you let u equal x, du equals dx. So this integral is going to become, instead of x squared, I write u squared. Instead of dx, I write du. Instead of 1 plus 2 x cubed will be u cubed to the 8th power. Making the substitution u equals x doesn't do anything other than change the letters in the problem. And changing the letters won't do anything. Okay, so we let u be that. So then du will be 6x squared dx. So the denominator, that's u to the 8. I took care of the whole denominator. Well, x squared dx, only I had the 6. Well, you do have it. Put it in and multiply by the reciprocal. So there is the 1 over 6 that I just put in. There's my 1/6. I took care of that. 6x dx, 6x dx is du, and the bottom is u to the 8. But I don't know how to take the integral of 1 over u to the 8. So I bring it to the numerator. Now it's u to the n du. Oh, that's an easy one. I add 1 to that exponent. I get -7, and then I divide by -7 plus c. So the constant is going to be -1 over 42 times that. But I'd rather have that in the bottom. So I'll divide by that and change the sign. Plus c. So the final answer is -1 over 42 times u to the 7th plus c. And u is 1 plus 2x cubed. And that's done. This killed off another problem. How about we consider this problem? 1 plus 1 over t all squared times 1 over t squared dt. Well, I'm going to call that u. So I know one thing, this whole piece will be u squared. Okay, so u is equal to 1 plus 1 over t. In anticipation of finding a differential, I'll write 1 over t as t to the negative 1. So du equals, that's going to be 0. You're going to get negative 1 t to the negative 2 dt. Well, that's negative 1 dt over t squared. Okay. Well, if I put a negative in here, and I take out a negative, because a negative times, that's like negative 1. It's like plugging in negative 1 and taking out negative 1. They multiply out to positive 1, which is what we want. This is nothing more than negative 1 over t squared times dt. Well, that's du. This part right here is du with a negative in front. But that's a simple integral. The negative stays. This integral is u cubed over 3 plus c. Okay, so we get negative u cubed over 3 plus c. Now u is, don't guess, is that. Now, that is not the wrong answer. But I bet if you looked in, say, the back of your textbook, or if you asked your teacher how to do this, he or she would write it this way. Okay, so you have negative this, which I wrote, and then you have negative c. But negative c, 7c, 3 plus 2, it's just plus c. Okay, if that c is negative 7, then this c will be positive 7. If this c was positive 7, then that c here is negative 7. It's just a c. It can be any number I want. But either one should be accepted without any question. So what I would do from right here is I would say it's negative u cubed plus c. I wouldn't, something's wrong. Negative u cubed over 3 plus c. I wouldn't worry about, so whatever answer you get, then say plus c. It'll never fail you. You don't have to have the plus c being associated with that negative sign like I did down here. But it's fine if you want to do that. Okay. Suppose you have this problem. The integral of y times the square root of y minus 2 dy. Now, if you can distribute the y, then you'll have y to a power plus minus maybe a constant y to the power, and that would be simple. But that square root is in the way. In fact, if it were just the square root of y, if we had, I don't know, y plus 3 times the square root of y, which I would write that way, we can distribute. It's just that we have y minus the 2. That's really in the way. And this is what's being raised to a power, 1/2. So let u equal to y minus 2. So bringing this to the other side, u plus 2 is y. I did it because I need to know what y is. And now, from here, du is just dy. So I claim I have everything that I can write in terms of u. Y is u plus 2. Okay? U plus 2. The square root of y minus 2 Well, y minus 2 is u, so have the square root of u. And then dy, that's du. You have to be honest with yourself. That is, each and every piece has to be justified for. Now, as promised, you'll be able to distribute, because it's just u to the half now, not u minus 2 to the half or y minus 2 to the half. So when you distribute, well, you're adding 1. We know how we're experts in adding 1. Just add 1 and 2. You get 3 over 2. Don't divide by 3 over 2 because we're not integrating yet. We're just multiplying out. Plus 2u to the half, all times du. Now we're integrating. Add the 2 and the 3, you get 5 over 2, and you divide by 5 over 2, plus 2. You add 1 plus 2 is 3 over 2. So you divide by 3 over 2, plus c. So this is 2 times u to the 5 halves over 5, plus 2 times 2 is 4, times u to the 3 halves over 3, plus your constant. And u is no guessing. U is right there. It's y minus 2. Honestly, and I'm not lying, I thought it was going to be the square root of y minus 2. But I looked and I say, oh, okay, and here is one way of writing the answer. I'm sure there are other ways. I mean, I don't know where you would get this other way from, but it wouldn't be wrong. Plus 7 plus c. That wouldn't be wrong. Just not sure how it would work out, but I would absolutely mark that correct. I'd put an equal sign there. Now, if I was really, I basically check equal signs. Now, if I made a big deal about you combining constants and you left your answer like this, well, then you would lose a point. If I was really big and I said, hey, anytime you can combine constants, do so, and I clearly didn't combine those two constants, I should just have written plus c, you lose a point. Now, let us just do one more problem. If you were given the integral of 8 minus x times x to the 3 halves dx, you should not do any U-substitutions. First of all, that's being raised to a power. So what are you going to call it? U? Well, then you would have u to the 3 halves, and x is that x, just like that x, is being called u. And if u is x, then du is dx. That is, instead of dx, I'll write du. We didn't get anywhere. We just changed the letters. So U-substitution, I don't even see how it would help here. I would just distribute. You will have 8x to the 3 halves minus x to the 5 halves. You want to add 1. Why did you want to add 1? Because that power is 1. When you're multiplying and the bases are the same, you add the exponents. Oh, I want to add 1 to that number. I'm an expert at that. 3 plus 2 is 5. Keep the common denominator. So the final answer will be 8x. 3 plus 2 is 5 halves. And then you divide by 5 over 2. Minus x to the 5 plus 2 is 7. So x to the 7 halves divided by 7 over 2 plus c. So the final answer will be 16 x to the 5 halves over 5 minus 2x to the 7 halves over 7 plus an arbitrary constant. And that finishes this section on integrating by substitution.